Dear students, I am going to present to you an important theorem pertaining to the bivariate normal distribution in that situation when x and y are independent. The theorem is as follows. If x and y have a bivariate normal distribution with correlation coefficient rho, then x and y are independent if and only if rho is equal to 0. ये जो मैंने अभी आपके सामने रखा स्टूडेंट्स, इसमें ये जो चार लफ्ज हैं इफ एंड ओनली इफ, इन पे आप गौर कीजिए. इसका क्या मतलब होता है कि दोनों तरफ से प्रूव होता है आपका थ्योरम. इस केस में व्हाट वी आर सेइंग इज दिस, that if x and y are independent, then rho will be equal to 0. And also, from the other side, if rho is equal to 0, then x and y are independent. So let us now try to attempt to prove this particular theorem. अब इसमें जो पहला पार्ट है स्टूडेंट्स, उसके सिलसिले में आप ये नोट करें कि ये स्टेटमेंट जो है, दिस इज ऑलवेज ट्रू. डू यू नॉट नो दैट दिस इज जनरली ट्रू, दैट इफ x and y are two independent random variables, then their correlation coefficient will be equal to 0. ये तो आप जानते हैं कि ये तो होता ही है. So therefore, there is actually no real need, in my opinion, to prove the first part of this statement, if and only if. The actual goal is to prove the second part of the statement, if and only if, yani to prove the statement that in the case of the bivariate normal distribution, if rho is equal to 0, then x and y are independent. So, before I present to you the proof of this statement, my dear students, let me discuss with you the basic condition by which two jointly distributed random variables x and y can be regarded as being statistically or stochastically independent. It is a simple equation. F of xy is equal to f of x into f of y. Yani, we can say that two random variables x and y are independent. खाली इंडिपेंडेंट भी कहते हैं, स्टैटिस्टिकली इंडिपेंडेंट भी कहते हैं, स्टोकैस्टिकली इंडिपेंडेंट भी कह देते हैं. दे आर इंडिपेंडेंट इफ द जॉइंट डेंसिटी f of xy can be factorized into the product of the two marginal densities, f of x, the marginal density of x, and f of y, the marginal density of y. तो इट्स अ बेसिक कंडीशन. अगर ये हम शो कर सकें कि हमारी बाइवेरिएट नॉर्मल के केस में भी रो के ज़ीरो होने पर ये हो रहा है, then we have proved the second part of the statement. But also, before I do that, I would like you to note another very interesting and important point, that because of this factorization, what happens to the conditional distribution? As you can see on the screen, we can say that the conditional density of y given x, which is by definition the joint density f of xy divided by the marginal density f of x, because of this factorization, this expression will be equal to f of x into f of y divided by f of x. So obviously, f of x will cancel out and we are left with simply f of y. तो इक्वेशन क्या बनी? स्टार्ट में देखिए क्या लिखा है और एंड में क्या लिखा हुआ है. हमारे पास क्या आ गया है कि f of y given x is equal to f of y. ये कब हुआ? When x and y are independent. तो ये जो हुआ, ये एक्चुअली क्या हुआ है? We can say that the conditional distribution of y is the same as the unconditional distribution of y, right? दोबारा सुनिए, f of y given x is the same as f of y. तो f of y given x तो obviously conditional distribution है, लेकिन जब हम सिर्फ f of y कहते हैं तो कोई उस पर कंडीशन नहीं लगी हुई. That's why I said that if x and y are independent, then the conditional distribution of y is the same as the unconditional distribution of y. वजह आप साफ जाहिर है कि जब x अफेक्ट ही नहीं कर रहा y को तो फिर ऐसा ही होगा ना. So now let us proceed to prove this second part of the statement if and only if. और वो statement क्या है कि in the case of the bivariate normal distribution, if rho is equal to 0, then x and y are independent. So what do I actually have to do in order to prove this? Well, all I have to do is to substitute rho equal to 0 in the PDF of the bivariate normal distribution. Obviously, that is what I have to do because we are saying that rho is equal to 0 and then we are wanting to see what happens to the PDF. तो अब आप उसके अंदर जब 0 रखते हैं तो वो simplify हो जाता है. And as you can see on the screen, what we get is this. F of xy is equal to 1 over 2 pi into sigma x into sigma y into square root of 1 minus 0 square. Now 1 minus 0 square obviously means 1. Square root of 1 is also 1. इसलिए वो we don't even need to write it there. And we simply have over there 1 over 2 pi into sigma x into sigma y. ये तो हुआ वो पार्ट. और जो एक्सपोनेंट है उसमें क्या हो रहा है? एक्सपोनेंट में e रेस टू जो है क्या है? -1 over 2 into 1 minus 0 square. क्योंकि रो को आपने 0 रखना है ना, तो वहाँ पे भी 1 minus 0 square is equal to 1. You don't need to write it, so you just simply get -1 by 2. और उसके बाद वो स्क्वायर ब्रैकेट, उसके अंदर वो जो 3 टर्म्स हैं उनमें से एक टर्म के अंदर रो आ रहा है और वहाँ पे अगर आप 0 पुट कर दें तो जाहिर है कि वो टर्म पूरी टर्म 0 के बराबर हो जाती है. And then you do not need to write it. So then what are we left with? We have e raised to -1 by 2 and then a square bracket with it, and inside the bracket x minus mu x over sigma x whole square plus y minus mu y over sigma y whole square. So students, now we can write e raised to all this as the product of e raised to the first into e raised to the second. और जो पहले लिखा हुआ है 1 over 2 pi into sigma x into sigma y, students, let us write it as follows. 1 over square root of 2 pi into square root of 2 pi into sigma x into sigma y. इसके साथ क्या चीज़ attached है? e raised to -half into x minus mu x over sigma x whole square into e raised to -half into y minus mu y over sigma y whole square. Then do you not see that what we have is actually the product of the marginal distribution of x and the marginal distribution of y? 1 over square root of 2 pi into sigma x into e raised to -half into x minus mu x over sigma x whole square, the marginal distribution of x, and the similar one in terms of y as the marginal distribution of y. तो आपने देखा कि एक्चुअली 0 जब हमने रखा रो को तो बड़ी आसानी के साथ ये जो लंबा चौड़ा एक्सप्रेशन था, it became simpler, and in fact the factorization happened very easily. So this is how we can say that the theorem is correct, that not only is the if part correct, but also the only if part is equally correct. And this is how we get this important theorem. Do please note that this property is not going to hold for every bivariate distribution that is there. ये हर डिस्ट्रीब्यूशन के लिए होल्ड नहीं करती. इट इज़ अ रिमार्केबल प्रॉपर्टी of the bivariate normal distribution.